As Christmas is coming up, I thought it would be fun to write a countdown timer app. Keep in mind that this is a walkthrough and not a tutorial on Pygame, which means I will be showing how I made it and not necessarily teaching what everything means. After this video, I will be having a 12 Days of Christmas series where I will upload 12 videos starting on the 25th every day, making a Christmas themed program or game to show off. So anyway, let's get into the writing. First, I will be importing Pygame, and I will be needing two other modules called time and date time. So import time, and from date time, I will need date time. And very first thing I need to do with Pygame is initialize it. Then I will make a surface, which is just an array of pixels that I can put other surfaces on, such as putting the player on my screen. So Pygame display set mode, and this will create my window with a certain resolution. So I'm going to be using resolutions throughout different files and throughout the code. So a way to make that global for me is by making another file called constants 1000. Okay, and I'm going to import that as well. From constants, import all, because I'm only going to have those two things in there. So when width, when height. So this is going to return me a surface that I can draw onto according to the window size and height that I have put as variables. So next, I'm going to change the caption of my window to be Christmas countdown, and then an instance of Pygame's time.clock to kind of get the time between frames, which is called delta time, and it's super useful for uniform movement between different refresh rates. I will write my main function here. Run is true, while true. Here is where I'll make my delta time. So using clock.tick from this class, so the tick is a method, and divided by 100, I can get the time between my frames. I will iterate through events in event.get, and if my event.type is pygame.quit, which is the X button on the window, or my event type is pygame.keydown, and if that's the case, I also want to check if my event.key is pygame.keyEscape. And if any of those things happen, then I want my loop to finish. Okay, and outside of here, Pygame display flip. And this is pretty much everything I need to get my basic window going. Down here, run my main function. So now that I have this, I have my window. Okay. And if you want to do this with me, I have a custom PNG and a custom font that I will be using. I will link those in the description through my GitHub. Now here I will load my wallpaper, Pygame image load, wallpaper, and .convert. So the difference between convert and convert alpha when with managing surfaces is that convert it's generally faster, and convert alpha is kind of for transparent images because it takes into account alpha pixels, alpha values. And the wallpaper is not quite the resolution of my window, so I'll just simply reassign the variable with a Pygame transform scale, which will scale my image to whatever dimensions I want it to. I'm going to pass in my surface, and I want it to be my window width and window height. On my screen surface, I want to blit my wallpaper onto it at coordinates 0, 0. If I run this, you'll see I have my wallpaper here now. Okay, let's start working with the time. So here, I want to get my Christmas time, which I'll be using date time for, and the year is 2022. If you're watching this in 2023, simply change this value to that. Month is 12, and day is 25. And down here, I want to get every single frame what the current time is. So current time, date time dot now, and if I print my current time, you'll see 2022, it's December 15th, almost 1 in the morning. And the way to get the difference between now and Christmas is simply getting my Christmas time and subtracting my current time. So there are 9 days, 23 hours, 3 minutes, and 6 seconds left till Christmas. And that's kind of the easy way around that. So I want to turn this into a variable that I can use. So time left, so that's going to be that. And let's start off by getting the days left. You can see, same as we just saw, 9 days left. And the only difference with this is that we don't have the option to simply get hours and minutes. We just have days and seconds. So if I print out my seconds, we can see how many seconds are left. All right, so now that we have that, I want to program a class that will have methods in it that it'll take in variables, which is our current time, and transform it to something that we can see on the screen, a text surface. So I'm gonna make a new Python file, and in here, import Pygame class timer. Actually, let's name this Christmas clock, Christmas timer. Yeah, init method. So self.font, I want to get my custom font. So I'll just simply import that at the size of 120 because it's a pretty big screen, 1000 by 800. And we don't have a current text surface because we don't have a time to present yet. So I'm just going to name it none for now. In here, I want to name a custom method called getTime, where I can get my days, which I showed earlier, and my time left. And you'll see why I didn't put seconds in here in a bit. So the reason I didn't put seconds is because I can actually transform those seconds into hours, minutes, and seconds. So back here, if I write a print statement, and this is why I imported time at the very top. Using time, strf time, here format a string of HMS for hours, minutes, seconds, using the seconds that I currently have. Okay, and this is a string we're going to format with the following tuple. So we have another time, GM time, and we're going to pass through the seconds here, and it's going to convert it to an hours, minutes, seconds tuple that we will format into our HMS string separated by colons. So let's get our time left, seconds. And here you can see 22 hours, 58 minutes, 54 seconds. So in our Christmas timer with the hours, minutes, seconds left and the days that we have already checked are working, we can make a formatted string, an F string, that will connect our days, which is a single integer, with the string we made earlier, being time left. So this is our formatted string that we will turn into a surface to put on our screen. So font render, I can put my formatted string in there, and true is the boolean that I have to put in for anti-aliasing. And the color I want it to be is a custom color that I used, 255, 25, and 25. Now, to actually show it on the screen, I need a draw method. So I'm gonna name it draw, and I'm gonna pass in my screen through here. So on my screen, I'm just going to blit my text. Let's start with 00 for now. So now that we got this prepped, I can import it. So from timer, import Xmas timer. And then right below my Christmas time, let's name it show timer, Xmas timer. And then down here is where I'm gonna get my time with the get time method. Show on my show timer, get time, you can see that it needs my days. So time left dot days, and then my time left. So I'm just gonna copy this entire line right here into here as an argument. So now we are getting this and turning it into our formatted string to turn into a text surface. And to show it on the screen, show timer, draw, and pass in our screen. Now when we run it, we can see that we have our timer counting down. Now we want it at the center of the screen, so we're gonna have to do a little bit of math for this. So to even kind of get the dimensions of the screen, you can already guess that from constants, import all. And instead of 0, 0, I want to get my window width divided by 2 minus my text width divided by 2. And then that'll be for the X offset. And for my Y offset, I want it to be my window height divided by 2 minus my text surface height divided by 2. So now if we run it again, you can see that it's right at the center of the screen. Now here's one cool thing about the font that I have is that parentheses are actually decorations. So if we run this now, you can see it's got a little bit of a splatter at the end, a little bit more decorative. So aside from this, the blank red does look a little plain. So what I did is add a bit of a shadow to it. And basically I just made a second text and blit it right behind it with a 5 pixel offset going to the top left. So first I made a new variable called shadow. And then down here, I assigned a new surface, self.font.render, using my formatted string, true of course. And because it's a shadow, this time I want to make it black. And shadow has to come before the blitting of my red text. So screen.blit, self.shadow. And I'm just going to copy this entire equation. And then simply add my 5 pixel offsets. So now when I run it, you can see it has a little bit of shadow to it. And the very last thing I want now is some snow falling. So this is where the math stuff is going to come in using trigonometry. So I'm going to make a new file called snow. And in here, course, import Pygame. And this time I'm going to import some functions from 2 other modules. So from math, I'm going to use the sine function and the radians function so I can transform degrees to radians. And the other module is going to be random. And from here, I want to use the randint function. And because it's snow and I am going to use dimensions of the screen, from constants, import all. Now we can start writing our snowflake. So I'm going to make a class called snowflake, and I'm going to inherit Pygame's sprite class, because it makes it super easy to kind of put this object into a list for me to iterate through and blit onto my screen surface, which will allow me to have a bunch of snowflakes on screen very efficiently. So init method, to automatically put this object into a list, I'm gonna have to make a parameter called groups. So I'm gonna call the superclasses init, which is the sprites init, and pass my groups through there. If I go back to my main, from snow, import snowflake. The way groups work is that, I'm gonna put it right here. I'm gonna make a snow group, Pygame sprite group, and whenever I call snow, it's going to put it into that group automatically for me to iterate through. So if I did this in my function, snowflake, snow group, and then I went down here for snow in my snow group, snow dot, let's say test for now. We don't have it yet, it doesn't exist, but we're gonna write it right now. So method test, we can print test. So now if I run it, you can see it's printing because I automatically put it into the group, we iterate over it, and we're printing it. So we're gonna delete this and put a past here for now. There's a couple of things I need to do to initiate my snowflake with a bunch of attributes. It needs to be random. The main things that need to come from this snowflake when coming down from the top of the screen is the direction it's gonna start moving in, the speed it's moving in, the amount of sway it has, and the spawn location on the x-axis. So first I'm gonna make a surface using Pygame surface, the size of 10 by 10 pixels, and surface, so convert. And with my surface, since it's just blank, I'm going to fill it with a solid color white. So here's where I'm going to randomize its positional values. So self dot start direction pretty much. I'm going to pick a random number between 0 and 1, either of those two. And I'm going to get a random X offset between 0 and my window width. So it's going to spawn a snowflake between 0 and 1000, which is the width of our window. And our position is going to be a Pygame vector, where the X position is our offset and the Y position at 0. So the actual issue with using 0 is that we're going to be blitting the surface at this position. And it spawns that surface pretty much the top left of it. So if our position is the top left of the surface and we start at 0, then we will be able to see the entire snowflake spawn at the top of the screen instead of coming through above. The way to fix that is to basically subtract with the height of our snowflake, which is negative self dot surface get height. So this will spawn it above the window and you'll be able to see it coming down instead of just appearing at the top. And here's going to be our movement traits. So because we're going to be using sine, we need an angle of degrees. So I'm going to start at 0, and our velocity is going to be a random integer between 9 and 15. I found these were the best numbers to have the snowflakes moving in. And our sway, or in mathematical terms, the amplitude of our sine wave in how far left and right our snowflakes are going to be moving. So I made it to where the faster the snowflake is moving, the more sway it's going to have. So I simply just got my velocity and multiplied it by 2. And this is basically everything we need in the init method. In here, I will create a method called fall and pass in our delta time, because anything that requires movement, it's suggested to use delta time for the reasons that I told at the beginning of the video. So in here, first we need to move our snowflake downwards. So let's do self.position Y, and because the Y axis is inverted in visual programming, we want to add to it for so it can go downwards. And what we're going to add to it is our velocity speed times our delta time. So if we actually make a draw method and put our screen in there, type surface, and then screen dot blit our surf at the current position, I go back here, snow dot fall, pass our delta time, snow dot draw, pass in our screen, we will see a random snowflake fall through. And now we want the snowflake to sway, and this is going to be the most mathematically intensive part of this walkthrough. Because the sway is left and right, that means the x-axis needs to be manipulated. So position.x, we're going to use the sine wave, and because our angle will be in degrees, we need to convert it to radians. So that's why I imported the radians function. So radians, self.angle, and multiply it by our sway, or in mathematical terms, our amplitude. Now, if you run it now, you can see that the snowflake will forever be spawning at the left side of the screen. And that is because we set it equal to this number, not taking into consideration that we had an X offset at the very start. So what I'm going to do is encircle all of this and then just add our X offset. So now we can see it fall at whatever offset we had it at the very start. Now it's not swaying now, and that's because we're not adding to the angle. Down here in another line is self.angle plus equals whatever our sway is times delta time. So now if we run it again, yeah, you can see it's falling through in a sine wave pattern. Now, if we keep running this, you'll notice a pattern that the snowflake is always going to start off moving to the right. To the right. And the way to fix that is by using our random direction of 0 and 1. If self.direction is 1, I want it to start off on the right. Else, I want to start off going to the left. And the simple way to fix that is subtraction. Now if we run it, you can see that one started moving to the left, and you could rewind the video if you missed that. Once we start spawning a bunch of snowflakes, there's no way of removing them from the list automatically. And the way to fix that is by simply saying, if our position Y is greater than the height of our screen, self.kill. And kill is in the sprite inheritance. So I use sprite to automatically put them in groups and to remove itself from the group that it is currently in. So in here, if I said print snow, you can see that we have snowflake sprite in one group, and once the snowflake reaches the bottom, 0, which is very efficient for our code. So the speed of the snowflake is random, the direction it starts in is random, the sway of it is random. So we basically got everything we need. Now we just need to spawn a bunch of snowflakes. And the way we're gonna do that is using Pygame's custom user event functions. And it's event timer functions. So below our snow group, I'm gonna make a spawn snow event that is equal to user event. And because user event for some reason by itself is already used and is not possible to use as your own, I'm gonna +1 Pygame time set timer, and you can see here it needs an event and an integer in milliseconds. So we want it to spawn our snow. That's going to be the event that is going to trigger, and I think it looked best at every quarter of a second, so 250 milliseconds. So now that we have our custom event made, we can go to our event handler, and if our event type is our spawn snow, make a snowflake. We can actually just copy this and put it here. Delete that top one. And now if we run this, we now see a bunch of snow that is spawning every quarter of a second. I'm gonna challenge y'all to making a menu where you can select what holiday you want a countdown for. I'll put my Discord down in the description as well, and I'll see you on the 12 Days of Christmas series.